Chapter 7, Lesson 1, Classifying Angles. Today we're going to learn to name and identify angles as well as finding a missing angle measure. So some of this is going to be really review for some of you guys and some of it's going to be brand new. So to start with, we're going to start with just a regular angle. Now a couple things that I'm going to be really particular on. An angle is going to have arrows on it unless it's part of another shape. So when I look at this angle right here, the corner piece right there is called my vertex. My E doesn't look very good. My vertex, okay? Now, based on how many degrees an angle is, sometimes they're given extra special names. For example, a 90-degree angle is a right angle, and that's probably something you guys have already been told before. An acute angle is something that is less than 90, so less than 90 degrees. And then an obtuse angle is going to be greater than 90 degrees. Now a new angle that we sometimes hear about is what's called a straight angle. A straight angle is just that. It's going to be a straight line, which means it's going to be 180 degrees. Okay? Now we're going to talk about vertical angles and adjacent angles on a different slide. So I'm going to kind of cross those off right now because we're going to cover those in a little bit. However, congruent means that they are exactly the same. So when I'm talking about angles, that means that if two angles are congruent, they have the exact same degree measurement. Sometimes we'll talk about congruent sides, and we'll get into more of that, but congruent means exactly the same. Now we have special symbols in math to cover. An angle is kind of like a less than sign, except the bottom is straight on the bottom of your line, and then you have your angle going forward. And so if I'm going to have a triangle here, and I'm going to label this point A, B, and C, and I want to talk about the angle at B right here, I can label that a couple different ways. I can label that as simply angle B, or I can talk about the points that lead into it, and I can label that angle A, B, C, meaning it goes from A to B to C. So two different ways to label our angles. Congruent has a special symbol, okay? So congruent means that we have exactly the same, so we have an equal sign, and then that special symbol on the top is how we write that. Now I said we were going to come back to vertical and adjacent. A vertical, two angles are vertical if they are opposite of each other. And it's kind of confusing because we think of vertical and horizontal. We think vertical typically means up and down. So I can easily see 2 and 4 are called vertical angles. But for whatever reason, they have decided that if they cross and are across from each other, so like angle 1 and 3, they are also considered vertical angles. Now what's really cool about vertical angles is that they always have the exact same degree measurement, which means that they are going to be congruent. So angle 2 and angle 4 are the exact same angle in terms of measurement. Now adjacent angles are angles that are next to each other. So angle 2 and angle 3 are next to each other. I could also say angle 3 and angle 4 are next to each other, so they're adjacent. And then also angle 5, so let's do that. Or I'm sorry, angle 4 and angle 1 are also adjacent to each other. So you can see anytime they're next to each other, they're called adjacent angles. So now here it says name the angle shown, then classify it as acute, right, obtuse, or straight. Okay, so it says name the angle shown, and I want you to name it in at least 2 different ways, even though there's 3 different ways. So pause the podcast and see what you can remember. So in this one, I could name the angle simply angle Y, because there's only one angle here, so that would be that. I could also name it angle 1, because there's a 1 on the inside. And lastly, I could name it angle, well actually there's two ways here, X, Y, Z, or angle Z, Y, X. Okay? Now, is it acute, right, obtuse, or straight? Well, it's obviously not straight, obviously not right. So now I have to decide, is it greater than 90 degrees or less than? Well, in this case, it's less than, so it's going to be an acute angle. All right, identify a pair of vertical angles and adjacent angles in the diagram at the right. Justify your response. So explain how you know those angles are either vertical or adjacent. So pause your podcast and do that now. All right, you'll see on your screen all of the vertical angles and adjacent angle possibilities. Now, vertical meaning that they are across from each other, adjacent meaning they're right next to each other. All right, this seems tricky at first, but I know that you guys can get this. It says, what is the value of x in the figure? So we've got to dig back to what we know. So we know that if we have a straight angle, so that's that straight line, I know that that equals 180 degrees. I also know a right angle is going to be exactly 90 degrees, okay? And I know that vertical angles are exactly the same. So I can see a couple things. I can see that 130 and 50 make 180, which is great, which means I know these two expressions also are going to equal 80, or 180. But I can make it a little bit easier because I know that 2x plus 2 is going to equal 130 because they're vertical angles. So I can find the value of x simply by solving just one of those. So if 2x plus 2 equals 130, we've got to think back to our problem solving where we had the different equations and we had to solve for a single variable using two-step or one-step equations. So really think back on that. So the first thing I need to do is I need to separate my additions, so subtract 2 from both sides. This becomes 0 because it's a 0 pair. So I've got 2x equals 130 minus 2 is 128. Now I've got to separate my 2 and my x, which are held together by multiplication, so I undo it by division. So x equals, now I do 128 divided by 2, which is 64. So x is going to equal 64 is what it's saying. So I've solved for x in here. You could, if you wanted to, go ahead and solve for y as well. 3y minus 10 would equal 50, and you'd be able to come up with that answer. In this case, we only needed to solve for x. All right, this is our last problem, and it says, what is the value of x shown in the sidewalk? So this is much like the problem we just did, however, they've kind of given it a more practical application. I want you to pause the podcast and then come back and check your answer. So in this one, I see that we have 115 degrees already, and then I have 5x degrees. Now what I notice is that when I look here, let me grab a color that's going to show up on that green. When I look at this, I've got this red straight line, okay? That straight line I know is going to be 180 degrees. So I know that if I take this 115 plus my 5x degrees, right? Then I am going to end up with 180. So my equation becomes 180 equals 115 plus 5x. So I know the first step is going to be separating the addition components. So I'm going to subtract 115 from both sides. So then if I subtract 115 from both sides, I end up with 65 equals 5x. So now to separate my 5 and my x, I'm going to divide both sides by 5. 65. So then 65 divided by 5 is going to be 13. So then my final answer is 13 equals x, which is what I needed to do, was find that value of x. If you're a little rusty on your solving with variables, make sure you do some extra practice, get some extra help on that, and then we'll continue working on all of these problems in class.